Hi guys, just having an experiment, but I thought I'd film it right from the beginning, so this may end up being a lengthy one. What I thought I would try and do is with an old IPM heatsink, that's the one I was using in the oven that you might recall from earlier videos. I've just put that directly onto the ceramic element, and that same T-con board I've been messing around with, I've just sat that on the top. And we've got three thermocouples connected to it. The two on the black holders are on that brass tube, and they both run up to individual meters there, and I think we've got 11.3 on those. The other one on the flexible arm is the one that's going to the REX C100, and that's on 10 degrees. What I wanted to see if we could do or achieve is just to ramp this up slowly and to see whether we can actually get this hot enough to lift any of these components off. I'm not convinced we can do that, but I thought it would be a useful thing to try. And of course, if it can get up to a proper reflow temperature, I'll be able to use it to remove the remains of solder on the back of the BGAs that as we take them off. If you remember from the last video, I wanted to, whilst the solder's still molten, just carefully wipe it off with this piece of silicone like that. When I tried it in the oven, it produced very good results, but of course it relied on the component being pulled out of the oven, and of course it quickly cooled down after that, so I need to keep it at the reflow temperature just while it's being wiped off. Yeah, so first thing we're going to do, I've set that to 30 degrees, and we're just going to fire up the element side. Again, I've left the lamp on for you so you can see when this is actually heating and when it isn't, and I'm just going to ramp this up over a number of minutes and see if we can actually get this to reflow. I'm not convinced. This is only what was it, I can't remember if it was a 650 watt element, but we're going to give it a go. So this could be a lengthy video with not a good outcome. You can always fast forward or skip through sections as this is heating up. Again, I've no idea what the overshoot will be on this from stone cold. We had quite an overshoot yesterday, but if you set the this value fairly low to start with, it's not so much of an issue. I've just taken this jig off of the oven, which you've seen in other videos, which is over there. It doesn't really fit this ideally. That power has gone off to the element now, and that's just happily overshooting to, I don't know, probably up to 50 if yesterday's experiments are anything to go by. From what I've seen on other rework stations, the ramp value is generally set for 1 degree per second, and this seems to achieve that or less, which again also seems absolutely fine. So obviously the heater, the element's now up to temperature, and it's just transferring the heat into that IPM heatsink and the board. We've got 55 on the thermocouple on the right, and on the meters we're talking what, 47 and 48 and 50. I think that's probably going to start dropping down any second, but I'm quite happy that that's probably just transferred the heat. So what I'm going to do is just increase the set value up to 60, and that should control it fairly accurately there. Hopefully the same results as yesterday, around the 4 to 5 degrees range. You have to question the accuracy of these thermocouples. At the moment we've got 54 on the left thermocouple, 54 on the right, and the set value is the process value on the REX is 62. And it's climbing strangely. I would have thought it would have been coming down. It's on 63 at the moment. There's obviously a fairly good amount of heat being transferred between the element and the heatsink. So it looks like that's stabilising. Yeah, it is, and now dropping back down. And we've got 55 on the left thermo couple, 55 on the middle, and 63 on the REX down here. Don't know why that's not dropping down quicker actually. Just waiting for that light to come on again. It's obvious because there's no gap between the heatsink and the element. It's obviously holding the temperature in a lot better. See that light? That's not actually triggering the element at the moment. It's just using the heat from it. Just dropping down again. That's got to trigger in a minute. That's got to be a good few minutes with no power going to the element. Again, it's cold in the workshop, but not really cold. It's quite a mild day. That has got to trigger any second, surely. I'm going to crank this up to about 80. Right, that's come on, as you can see. I was going to increase the set value to 80 immediately, but I'm just interested in seeing this under and overshoot. See what we're going to get now. Thermocouples on the other meters are reading around the 50 and 53. This is going back up again now. Right, so as soon as I've seen what this overshoot is, we'll just increase the set value. Because this could be much more stable perhaps like this, with this heatsink taking up a lot of the heat and being in direct contact. Oh, here we go. No, so it's going up, isn't it? So Well, as long as that doesn't rise above 65, then we're looking at a similar overshoot as we had yesterday. So, 66, so 6 degrees. So that's about the maximum overshoot. Oh, yeah, so that's actually overshooting quite substantially now. That's 10-degree overshoot, although I'm getting 60 degrees and 62 degrees on the other thermocouples. Well, I'm going to increase this. Let's get this up to 100. Well, actually, I'm going to put it up to 100. I was going to say 120, but let's see what the results are from 70 to 100. As you can see, I'll just zoom in on this. I might have not done that earlier on. I just want to show you where the thermocouples are on this. The centre of the element is probably the chip you can see on the left. Let me just point that out. That's about the centre of the element, but that's, I mean, I'm quite happy to remove either of these, but we're measuring really for this chip. I have got the fans going in the case today. Just wanted to see how the case temperature behaved with the fans on. I have to say, nothing really got very hot. When I took this, I took the lid off the other day because I hadn't connected the LEDs for the power onto the case and the individual LEDs for the fans that are fitted to it. So I had to lift the lid off on the element, and just the power supply case that the element sits in was warm. The surrounding areas and the power supply were not too bad at all. No particular issues worth worrying about. Alright, so where are we? We're up to 91 according to that, but only 80 and 76 on the other thermocouples, and I'm just going to move them actually and just see if we can get a better reading. Yeah, both up to about 90 now. I've just moved them a little bit closer around that chip. Probably the set value one should be more. Oh. You're seeing this fluctuate now. It's because I've moved the thermocouple to another location. Right, so what I've done there is the set value thermocouple is now just to the right, sorry, just to the left of that chip. It's pretty much in the, it's just off the middle of the centre of the element. Yeah, these tally more closely now. We've got 121, 112 and 118. Just zoom out. Obviously the chip quick is now molten. That's around that chip. I think we can safely ignore the overshoot and everything at the moment because I moved the thermocouples. Let's just crank this up. Let's see if we can get it to 160. Actually, you know what, I'll put it to 150 and once it stabilises we'll knock it up, because that's going to overshoot, I'm guessing, by about 10 or 12 degrees. So as long as we bear that in mind and keep within the tolerances of the chip, hopefully this will be okay. Just moving the set value, sorry, the process value thermocouple, because I'm not really happy with, that's it, that's in good contact now, so that's going to fluctuate quite a bit. I've got it positioned flatter on the board now, so that's really going to overshoot, I should imagine. We've got 160 on one of the meters, 170, yeah, so let me show you those. The one on the meter on the left is the thermocouple right at the back off the edge of the board, so that's going to be cooler. 162, that's just to the right of the chip, and we're getting 178 on the one at the front of the chip. It's 179 now, set value is 150. What I'll do is I'll just crank this up to match the process value, see if we can get it stabilised. There we go. Let me just zoom out again. Looks like we've got a Duff fan. Just going to leave the one fan running. Looks like we're going to have to fit a new fan in there. So that seems fairly stable around the 180. Thermocouple contact just seems absolutely crucial. The process value thermocouple is lying flat along the board. These other two on the meters have got the bead pointing down. So ideally it looks like this needs to be flat on the board. That's controlling that fairly well now, I think. So let's see if we can just pop this up to, well, let's do it carefully, let's do it 90 now, sorry, 190. See if I can zoom in so you can see what I mean about the thermocouple. Yeah, I'm not sure you can see from there, but the thermocouple back left is pointing down, the tip of the bead is just resting on the board. The one at the front there, I don't think you can see it, but the thermocouple lead is lying flat across the surface of the board, and the one behind it you can't even see anyway, so I might move this tripod in a minute, give you a better look. So we're heading up to 186 now. Well, nobody can say this board's has been heated too quickly. Right, let's watch the overshoot here then. I'm guessing it's going to be 6 or 7 perhaps. But again, we're within spec of where we want to go to. And once that overshoot's settled, I'll just ramp the set value up to match. and then it should hold around that new figure. Yeah, so I'm just going to run this up to 200. There we go. That should only be turning the element on for a few seconds, I would have thought. On the other meters that aren't in good contact, we've got 170 and 160. So I'm just going to ramp this up to 210. See how far out those thermocouples are because they're not in proper contact with the PCB. We are now at coming up to 210. Just let that overshoot and then pop it up to 220. Like that settling down a little bit more. I'm just going to let it get to its highest overshoot figure and then raise this to 220. That looks like we're probably about done. There we go. Let's see what that does now. Now this is where I guess it gets a bit critical. We don't want it overshooting by massive amounts at this temperature. The IC I want to remove is fairly loose now. Unfortunately, I've got so much chip quick around it that it's probably going to be sucking on there quite nicely. I think that's holding that fairly accurately. I'm just going to move the tripod and zoom in and we'll just have a little look and see what's coming off and what isn't coming off on this board. Hopefully that will focus. Come on. Right, just going to, hopefully you can see this. Where are we? I'm just going to see what moves and what doesn't. A little surface mount resistors all scraping off. So yeah, you can see that that's at Reflow around this chip. That's all the surface mount devices around it coming away. I have a sneaky feeling that this has got so much stuff on it, it's going to be impossible to lift off cleanly. I'm just going to move my hand around. I'm not sure whether you can see this very well or not. There we go. So that's off, despite having all that chip quick all over it. Hopefully this is still focused for you. Everything else in the area is, yeah, as you can see, there's a few loose components, and that's holding it. No, actually that's dropped, and maybe I've moved the thermocouples. Yeah, the temperature's dropped down now. I suspect it's because the thermocouple was in this chip quick. Yeah, the components are still loose around the edge there. As you can see, hopefully they're just wiping off in this sort of area. This chip is not to temperature, I don't think. Oh, actually it is. This sucker's a bit worn out. Yeah. Everything else around the edge, it's just in that central area that everything's fine. You can't get that connector off or anything like that. So yeah, I'm just going to remove the heat from that. There we go. Yeah, various components loose on here. So yeah, well, that's fairly successful then. I'm quite pleased with that. We can actually get up to proper reflow temperature. Just going to swing these out of the way and get these thermocouples out of the way. So yeah, that is not a bad result. So it does look like I will be able to use this heatsink to clean up any solder from BGAs that have been removed. No problems at all with that. So yeah, sorry you guys, that's a fairly long video, but I thought you might want to see this from start to finish. And actually I'll probably just lift this board off with some pliers and give you a closer look. Of course I've been scraping around with this, and we've got chip quick. This is only a practice board, obviously. No real signs of any heat issues. It's obviously all chip quick still molten, obviously, but yeah, fairly successful test, I think. So the idea would be just to pop the BGA onto here and bring it, well, it would be at temperature almost anyway, because I would put the BGA on there directly after it had been removed from the board, so it would only lose a matter of a few, well, I don't know, 10, 20, 30 degrees. Pop it straight onto there that's at temperature and just carefully wipe the residual solder off of the BGA. So yeah, there we go. I'll catch you later on.